Hi guys. What I'm going to be doing today is running an experiment showing what happens when the machine is running in the sweet spot from a voltage standpoint and from a primary mover input standpoint, how it drops off and the progression that we'll see on the amp meter here as I turn the machine on and run it, spool it up to what I consider its sweet spot. And then I'm going to essentially measure the voltage output at that point in time. I'm going to then disassemble the capacitor from the situation and discharge the capacitor and then take another measurement with the capacitor to see what the machine is producing at that standpoint. And then we're going to be also noting what the amp draw is at that said point when it's running in its sweet spot. And then what I'm going to do is dial the machine back down to prior to the sweet spot standpoint to show you what the machine is making in the non-sweet spot zone. So it should be fairly interesting, and I think what we will see is that at a specific amp draw for the primary mover in and out of the sweet spot, it produces much more voltage outside of the sweet spot than it does in the sweet spot. So the question is, why is it making a specific voltage in that zone, and why is it to such a great extent different than what it is when it's not in the sweet spot? So here we go. So we're going to start running it up and get this machine going. So what I'm doing right now is I'm just going to set it to a nominal 2 amps. So thereabouts, okay? Now we'll note the voltage here. Okay? And we are running a 20 microfarad capacitor to the outer portion slip rings, and I'm running a 15 microfarad capacitor to the inner portion slip rings. So this is where it is at right now at approximately 1.95 amps, producing this type of voltage. Now what I'm going to do is I'm going to ramp this up, and you can hear the increase in RPM. So here we are now at approximately 4.3 amps input, and we are at this voltage. Now I'm going to take it up a little bit higher. And now this should start to take off on its own. Here it goes. Okay, so now it's running in what I would consider its sweet spot. So if you notice here, it's at 2.1 amps. And this is what it's producing on the AC side. I'm going to disassemble this now. This is what's measuring off the capacitor at its maximum input. So we're going to dump this and measure to see what's coming out of the machine in its automatically speeded up zone. So I'll disassemble it from here. And I'm going to dump the cap. My cap dumping setup, which is a motor and a light. Okay, so there we go. So now we should have the cap pretty much back to 0. We have a nominal 2 volts in it. The machine is still running in the sweet spot, is approximately 53 volts AC. We're going to hook this back up right now. And you can see this is what the machine is producing in the sweet spot zone. So it's around 82 volts DC, 53 volts AC. This whole area around the machine, even out as far as this, actually feels cold. And again, I'm not saying that as a thing just because of the wind, but it actually does feel cold, and it's interesting. And the primary mover, again, is 2.1 amps, about 54 watts, running one side of the armature. Now, what I'm going to do now is I'm going to decrease the primary mover to get it back down to a lower RPM, and you're going to see initially this amp draw is going to increase and then it's going to decrease, and I'm going to try to dial it back down to 2.1 amps just to show you again what it's making DC versus AC. Okay, so I'm going to disassemble this for a second. I'm going to dump it again just so that we have it empty. Okay? And believe it or not, you didn't see any type of flash there, but it was 80 volts, which is interesting. Now I'm going to decrease this down. Decreasing the RPM. Now watch the amp draw increase. See, there it goes. Okay, now I'm at 4.25 amps. And again, that was with the decrease in RPM. And I'm going to start dialing this back. It's again 226 volts. I'm going to dial this back to 2 amps. And the RPM will go much lower. Really sensitive on the ESC. I'm just going to leave it at around 2.4. So in any event, there it's producing 160 volts AC. We'll see what it hooks up to as a DC output. So I'll show you that in a second. So here you heard the machine speed up. Now it's slow down again. So that's what it's producing at a lower RPM. 2 amp draw, so that remained about constant. It's interesting, and again the question is, when it's running in its sweet spot, it's still producing 60 volts and 80 volts AC and DC respectively, whereas if it's running at a lower RPM, and yet that it's a higher RPM, and at a lower RPM at the same primary move amp draw, it's producing much higher voltages. So it's an interesting situation. And again, I'm just going to ramp this up slowly to show you again until it automatically speeds up on its own. So this is at about just under 4 amps. That's at almost 6 amps, and then as I speed it up just a little bit more, it's going to unload. There it goes. And all of a sudden you see the AC voltage drop, the machine spontaneously speeds up, and I'm guessing we're going to see probably less than, about 2.2 amps drawing in this quote-unquote sweet spot. And I'll dump the cap again and I'll show you where we're at. Here's the DC cap going into the equation, and that's what it's making. Running at this RPM, and again, there was the capacitor was just placed on there. This is in its spontaneous speeded up zone, producing basically 80 volts, whereas at a primary mover input draw of 2.2 amps prior was making a couple hundred volts. So it's very interesting. Now the question is, why this voltage? Why doesn't it dissipate all the way? Something to think about.